Hello, and thank you for tuning into Answers from the Lab, where we share Mayo Clinic knowledge and advancements on the state of testing and science from laboratory leaders and the people who are making it happen behind the scenes. I'm Dr. Bobby Pritt, the chair of the Division of Clinical Microbiology in the Department of Laboratory Medicine and Pathology at Mayo Clinic in Rochester, Minnesota. With me today is Dr. Bill Morice, the chair of the Department of Laboratory Medicine and Pathology at Mayo Clinic and the president of Mayo Clinic Laboratories. This is our weekly discussion with Dr. Morice, in which we learn about updates in the field of laboratory medicine and pathology.
Well, hi, everybody. Bill Morice here with our weekly podcast. This week, Dr. Pritt has the well-earned time away from work, so I'm kind of handling this solo, but not truly solo, because I'm joined today by one of the newer additions to the Mayo Clinic staff in the Department of Lab Medicine and Pathology. He was doing some really exciting stuff in our field, but in a new way with new perspectives, and that's Dr. David McClintock. Dave, welcome.
Thank you very much.
So maybe just a little bit kind of about your background. You know, your interest really is in the sort of the where we're headed with computational pathology and clinical informatics, and just maybe just a little bit about your background and how you got interested in this field and what you've been doing in it.
Sure. So I kind of have a roundabout background. I got interested in informatics when I was a resident, and basically I was the only kind of person in my residency program who had an interest in computers at the time, right? So when I first started this back in 2005, 2006, it became you were the computer guy in residency. And what I discovered as I went forward is that informatics is so much more than just knowing about computers. It was all about how we deal with information, how we deal with laboratory data, and how we look at those workflows that surround laboratory data. And that was really the exciting part of me. I ended up approaching all of my different lab rotations or residency as with an eye of how do I look at making the workflows better? How do I look at making this lab information better? And in fact, I kind of look at what I call pathology informatics or clinical informatics is really being how do we deliver the right information to the right person, right place, right time, and in the right way. And we try to tackle every one of those problems that we have in informatics that way, because that's really the main thematic elements to any kind of informatics issue that we have, really, is that what is that right information? Who's the right person we're trying to deliver it to? What is the right way that we want to get it to them? What's the right place? What's the right time to do so? And all that comes into play whenever we deal with an informatics issue.
Got it. So that's during your pathology residency, right? As you were training to
Yes.
be a pathologist. So you were kind of big data before big data was cool and thinking about that. And so it must have been, did you have a hard time kind of getting people understanding what you were interested in? You know, I think back to 2005, people look at you like, what's this guy talking? Isn't he a pathologist? Why is he talking about computers? Did you get some of that?
Yeah, there was a lot of that. I mean, at the time, we had a lot of paper-based workflows. We had a lot of things going on where people, I had a lot of pathologists early on. We started looking at digital pathology and whole slide imaging, where they're looking at the slide scanner going, I'm never going to use a slide scanner. Why would I ever do this? Glass is perfect, glass is king, that kind of stuff. And it took some time over the years to get people to understand what the benefits would be. And that's really where the excitement is right now, is this idea of how do we take the data coming off of our digital slides and how do we repurpose that data to do so many more things than that the glass slides can't do, right? And so it's looking at that pixel data information from these slides and going, hey, what is this going to show us that we never had any idea about before? And that's the exciting part of what we're looking at with applying computational pathology and AI to anatomic pathology.
Got it. But you think beyond, because we really talk a lot about digital pathology. We had Dr. Hip, who's also joined Mayo, and you're on his team. But to me, it's a lot bigger than that too, right? Because it's great to go in this era of digitization of the slides, but there's all sorts of other data that's been data and for years, right, that we can tap into. So in some ways, it allows the slide-based workflows to catch up with all the other workflows in pathology, I think, right?
Yeah, I mean, that's the real cool part, is that we can now begin to take multiple sources of data and bring them together. So for example, we can take our clinical laboratory data, our radiology data, our molecular data, all the different sources of data that we have, all the data that's in the EHR, and begin to combine them with our anatomic pathology data again now as well. And since it's all digital in a sense, we can then go ahead and look at how we create these new algorithms that can then be tied to patient outcomes or even to things like operational metrics to go ahead and discover new ways of doing things. So for that, that's really the exciting part. There's so many different questions that we have and so many different ways of trying to find those answers now with these new sources of data that we're discovering.
Yeah, I mean, that's really cool. I mean, because to my mind, there's all this, and as comes up just in any conversation around AI, our cars going to make, there's going to be driverless car. No one needs a license anymore. And in pathology, it's like, these machines are going to be, you'll walk into my office and you'll just see a whirring machine, and I'm making espressos. That's how people view it. But as you talk, to my mind, it really is taking the work that we do, both as interpretive laboratory medicine professionals and pathologists, and having a system that actually works for us to make those observations, right? And then the other side, a big job of what a lab director does is thinking about how to make their labs more efficient. And this gives us whole new insights on that too. So it's not really replacing us. It's just giving us a lot better tools on kind of both sides of the equation to make the work we do much more efficient and much more actionable for our patients, right?
Yeah, I mean, that's really the key. We're not trying to replace anybody. We're trying to find ways of doing more with less, right? So in this economy and the way this world's working now for us, we're finding that with staff shortages and everything else, we need to find ways to do more with less, be it a pathologist, a lab technician, lab technologist, no matter who you have, we have to try to do more with that. And so being able to properly leverage our data for any type of questions, such as how do we, for example, how do we process more samples in the clinical laboratory without having to have people review them, right? Or without having to have someone manually review a result before it comes out. Being able to apply auto verification, something that's been done in the core labs for years. How do we apply it to more and more areas of the clinical laboratories that typically have had to use manual eyes to check things out? Can we do that in ways now using AI that allows us to be much more efficient in what we do with a really high quality of service? So those are the ways that we want to try to do that, where we're assisting the people who are doing the actual work, but we're not replacing them, right? And the same thing with pathologists in anatomic pathology. We're trying to develop algorithms and ways of helping them do their work more efficiently, eliminating the unnecessary steps that they're doing now with a lot of manual entry. Like maybe we can start forwarding this information that we collate and aggregate together so that their reports are automatically pre-populated, and that there are predictions as to what you're going to put in certain areas, just to make your life easier, right? And so that you're doing more review instead of the manual labor of actually trying to aggregate all this stuff together. So all that kind of work is something that we can really focus on to make lives easier, along with improving quality.
Yeah, I mean, that's to me the exciting part of all this. It's funny because you started talking about being the pathology trainee that was interested in computers. We don't think about that as a people problem, but the reality is that what this can unlock for us is everyone in any job, and especially in the labs, know that there's stuff we do every day that's not value add to our work, right? And those are the things that kind of drag us down, and particularly now coming out of COVID, where there's just a lot of burnout in the labs and burnout in healthcare in general. I mean, to me, these are going to be the tools that actually help make our work more rewarding. So it's all about the people as opposed to not about the people at all in some ways. Very exciting stuff. But so it sounds great. So we've probably gone from where you were in 2005 to people kind of looked at you like like you just dropped in from Planet X, to now people are excited about it, right? So, but what do you see? Because you've lived in the practical of trying to get these things applied. I mean, what do you see as some of the main challenges that we'll have to address to really get to where we want to go with all these tools and all this data and everything else?
Right. There are a few big challenges. I mean, one of the first is getting the data out of the systems that we have, right? So a lot of times you think, oh, our data is already digital, right? It's already in the LIS. And the fact is, a lot of LISs don't have the most easy database schema that we can use to get data out of it, right? We don't have easy extraction methods. The LIS is somewhat of a most LISs are kind of dated in terms of what they were built upon, and few companies have want to go back and just kind of totally disrupt their entire product and rebuild it from the ground up. That makes it much easier. So for them, it's one of those things where just trying to get the data out of the LIS or out of any of our middleware solutions that we use in conjunction with the LIS is difficult. Trying to figure out how to get the data out, put it into a useful data warehouse or data mart that allows us to really get that data and use it for simple things like analytics, reporting, and then later on for machine learning and AI is not the easiest thing to do. The second thing is we're looking at what are there. Like I said, there's so many opportunities. How do we prioritize what's the most important opportunities that we have, right? So it's kind of like simple project prioritization. There's so many things that we can do. How do we develop criteria that tells us these are the most important things that we do? Do we base it off of patient care, clinical care? It seems like they'd be the most natural choice, but sometimes those are the hardest projects to do. And so maybe we should be focusing more on efficiency, operational tools that then get us to that point where we can do better clinical care. There's big questions as to what makes the most sense to do first. And so I think those two areas of prioritizing our project, prioritizing what we really want to do. And the second thing is getting the data out of our systems and looking at what systems and where that data lies for a lot of the different things that we want to do. That's a lot of the work that we have to do right now to build that infrastructure so that we can then do AI and machine learning appropriately.
Got it. Yeah, that makes a lot of sense. Just in case people listening, LIS is a lab informatics system, correct? So
yeah, lab information system, yeah.
Yeah, and so I mean, what you're saying is that basically these things were designed at a time when no one was thinking about someone wanting to get all the data out and doing all this cool stuff with it. So there's lots of just very blocking and tackling type things. And to your question, then what do we work on first? And those go hand in hand because we have to design the systems to feed the questions that we want to answer. We have to do kind of both at the same time. So there'll be a lot of work to be done to achieve that promise, but sometimes we can be overwhelmed by the possible, but that's why it's great to have you here. So look, this is great. I'd love for you to be able to come back with sometime Dr. Pritz here too, and we can maybe bring Jason and talk about the things that we are doing. And I know there's a lot going on already with this, but so just in closing though, I mean, you feel very hopeful that this is really like in 5 years, we're going to be able to get to a state where this is really going to be making a difference in how we do our daily work?
I think so. I think at this point, a lot of places are beginning to buy into this. There's a lot of movement with the larger companies, the larger EHR systems who are realizing they have to accommodate and figure out ways of getting the data out and to allow groups to develop their own algorithms to use them within these systems. So we're seeing a lot more efforts by these bigger companies and to develop a better platform, right? And in fact, obviously, I know with Mayo, we're obviously interested in this as well. So as we begin to look at how do we develop platforms and how we develop these systems that allow us to do this kind of work, we're going to see a lot of movement in this space as people realize the like I said, the tremendous value that AI machine learning can bring to their practices. Yeah,
that's great. And I think going full circle, really, it'll require not just people saying it's Dr. McClintock's job to think about this, but we all have to think about this together, going all the way back to specimen collection. And because the more complexity we have, different tube types, all that has to feed in. So you start thinking about how do you continue to simplify with a future state of being able to do as much as possible with the information. So it's really exciting times, big changes, but really exciting. So that's great to hear it straight from you, from the expert, about where you see us headed. And really just want to thank you for taking a little time today. And hopefully we'll be able to have you come back in the future and fill us in on what's happening.
Well, great. Well, thank you very much too. It was great being on it.
Thanks.
Thank you so much for tuning in to Answers from the Lab. Be sure to subscribe to this podcast and don't forget to tune in every Thursday and every other Tuesday.